Do you remember that old fable about the chicken that laughed at people for burying their grain in the dirt instead of eating it right away? We humans often react the same way, surprised when scientists spend huge amounts of time and effort studying things that, at first glance, seem to have no practical use. Hey there, everyone! For example, why should we even care about the shape of the Earth's core? This unseen thing is located incredibly far beneath our feet. To be more specific, the outer core is about 1,795 miles below the surface, while the inner core sits even deeper at roughly 3,220 miles down. Welcome to our channel. It might be hard to believe, but our everyday lives are deeply connected to the shape of this hidden part of our planet. More accurately, life on Earth depends not only on the shape of the core, but also on other factors, especially the magnetic field it produces. So, let's take a moment to go through everything step by step. Alright, let's dive in. The core and the magnetic field. A magnetic field is the force that surrounds any substance carrying an electric charge in motion. It influences charged particles and materials that have magnetic properties. Magnetic fields also form around conductors that have electric currents flowing through them. But magnetic fields aren't created only by moving electric charges. There are three additional known sources: magnetic materials like ferromagnets, the Earth's core, and certain processes inside stars. Earth's magnetic field is generated by its inner core, which is made mostly of iron and nickel. This natural furnace, with temperatures above 9,000 degrees Fahrenheit, lies about 3,220 miles beneath the surface. Inside it, the motion of liquid iron and nickel creates electric currents, which then generate the planet's magnetic field. That field extends far into outer space and forms what we call the magnetosphere. This magnetic field is what protects us from the solar wind, a powerful stream of charged particles constantly blowing out from the sun. Life on Earth began under the shelter of this magnetic shield, like being covered by a protective umbrella. Without it, life might not have existed at all, or if it did, it would have been something completely different. And without this phenomenon, we wouldn't have technologies like electric generators, MRI machines, or hard drives, since all of them rely on the effects of magnetic fields to work. Is the core changing shape? In recent years, our understanding of Earth's internal structure has shifted dramatically. Scientists have come to the conclusion that the core might have a shape very different from what we have long assumed. And now we've arrived at the issue of the core actually changing shape. Of course, we shouldn't get swept up in the panic stirred up by news headlines claiming the core's rotation is slowing down. Sensational claims like Earth's core has stopped and the magnetic field will vanish soon are, to say the least, far from reassuring. These stories about a slowing or even stopping core rotation are based on changes in how fast seismic waves travel through the core, but the interpretation is often inaccurate. If something like that were really happening, it would bring catastrophic consequences for life on Earth, yet no such effects have been observed. In fact, according to a fairly recent scientific theory, the core is undergoing something called superrotation, meaning it's spinning faster than the rest of the planet. When you remember that the solid inner core sits inside the liquid outer core, this kind of physical behavior starts to make more sense. So, when scientists said 2 years ago that the core had stopped spinning, they were actually referring to the end of this superrotation. What really happened is that the inner core slowed down slightly and began rotating at nearly the same speed as the rest of the Earth. Changes in the core's rotation speed like this are believed to follow a repeating cycle. But what does this have to do with the core changing shape? It turns out that the observed shifts in the speed of seismic waves may not come only from rotation changes, but also from changes in the structure and shape of the inner core. These kinds of changes might also follow a regular pattern, and some of them could even happen during the same year. A paper published in February 2025 in the journal Nature Geoscience focused specifically on this possibility. The idea that the solid core of Earth might be changing shape can be explained by the unusual behavior of materials under extreme heat and pressure. Right at the boundary between the outer and inner cores, the material is thought to have a dense but uneven structure, like a tangled nest of liquid iron, with a mix of properties from both solids and fluids. After analyzing 121 earthquakes where the epicenter and the measuring station were located on nearly opposite sides of the Earth, scientists concluded that the inner core isn't a perfect sphere. It deforms in a cycle, stretching and flattening over time. Fortunately, these changes are small. If they weren't, they would cause sudden and dramatic shifts in Earth's magnetic field. There are also processes happening in the mantle that can influence the magnetic field in indirect ways. Thanks to recent studies, our understanding of Earth's interior has advanced quite a bit, and we're now starting to uncover details that were once completely hidden. Then again, calling something like an LLSPV, an enormous slow-speed zone, a detail might be pushing it. An LLSVP covers a region several thousand miles wide, and its total volume adds up to about 6% of the entire planet. These areas are marked by a noticeable drop in the speed of passing seismic waves. In fact, it was through seismic observations that researchers were first able to pinpoint this giant bubble inside the mantle. Even now, though, the origins of the LLSVP are still being debated. According to one theory, the LLSVP could be made up of leftover fragments from a hypothetical planet called Theia, which may have collided with Earth around 4.5 billion years ago. Part of that planet is believed to have formed the Moon, while the remaining debris was absorbed into Earth. A recent article in Nature suggested that this region is at least 1 billion years old, and maybe even older, which adds weight to that theory. This leads to a new question. How did scientists figure out how old these deep structures really are? What helped was the study of how seismic waves behave as they pass through layers of rock with different microscopic textures. Researchers discovered that the speed of seismic waves depends on how many boundaries exist between the crystals and grains that make up a rock. The more boundaries there are, the slower the waves travel. The fewer boundaries, the faster they move. So the smaller the individual particles are, meaning the more grain boundaries there are, the more slowly seismic waves pass through. Based on this idea, scientists now believe the mineral crystals inside the LLSVP are likely larger than those in the surrounding areas. And that means those crystals had time to grow to that size, which suggests this region is very, very old. A potential threat. Does a change in the Earth's core rotation speed pose a threat to humanity? That exact question is what triggered the wave of dramatic media coverage. Headlines everywhere claimed that Earth's rotation was mysteriously speeding up. If we want to respond clearly to the media-fueled panic, here's the short version. There's no need to worry. Even if the core's rotation speed changes, it won't bring any kind of disaster. Tabloids and pseudoscience magazines may scream that a global catastrophe is coming if the core stops spinning in 2040, but all of that is just exaggerated hype meant to grab attention. Almost all celestial bodies spin. The solid Earth itself rotates in a mostly uniform way. That consistent rotation is what gives us our standard measure of time. 1 second is defined as 1/86,400th of a day. Still, this system isn't perfect. In reality, Earth isn't a perfectly uniform object. We've known for a while that inside the planet are layers: the mantle, the outer core, and the inner core, all rotating at slightly different speeds. There are also processes happening inside the planet, and others involving shifts in mass within the atmosphere and oceans that affect how fast Earth spins. These changes make the length of a day fluctuate by just a few milliseconds. One example is the tidal forces caused by the Moon's gravity, which gradually slow Earth's rotation. Not long ago, scientists proposed that the inner core might not be able to keep up with this slowdown, and that idea helps explain what's known as the superrotation effect we talked about earlier. According to experts, changes in the rotation speed of the core could shift the length of a day, but just by a few microseconds. Of course, these changes are so small that only the most precise instruments can detect them, and there's absolutely no risk of a disaster. Scientists have been tracking these shifts for quite some time, but it's only recently that we've been able to explain them properly. A research team in China suggested that the direction of the inner core's rotation might shift in a repeating cycle roughly every 70 years. About every 35 years, the rotation seems to reverse. The inner core is linked to the mantle through gravity and to the outer core through the magnetic field. That's why researchers believe this process might be the cause of the known phenomenon where the length of a day changes every 60 to 70 years. The fact that these processes are all interconnected also helps explain the behavior of Earth's magnetic field. If you enjoyed this video, feel free to give it a like and share it on social media. Thank you so much for watching. We'll see you next time. Take care.